Okay, everybody, good afternoon, at least if you're in the UK, good morning if you're over in the States, and probably around midnight if you're watching this from Australia or China. So I'm Steve Hall, Chief Exec at Society for Underwater Technology, and this will be the first of what we hope is a regular series of online uh, seminars, webinars, whatever we're supposed to call them these days. We haven't really done these before, so bear with me if it doesn't all go incredibly smoothly on the first attempt. For those of you who've been following our social media feeds, you'll know that we're also planning to start a regular weekly podcast. Still on target to get the first one out on Thursday, and we'll be propagating the information about how you download that as soon as possible. Right. So my theme for now is just a brief introduction to some of the new ocean technologies which are coming online in the next few years. Some of you will be well aware of these technologies. For others, some of these might be quite new. Just by way of introduction, the little orange colored AUV in the corner there is the Bridges deep water glider, 6,000 meter rated glider, which is unusual for gliders. They tend to be shallow water beasts. And Bridges was a program that SUT were directly involved with to help Alcimar, the French manufacturer, develop a very deep ocean rated AUV that was optimized for use for things like the deep sea mining industry in the future. So we'll talk a little bit more about Bridges as we go on. So first thing I need to figure out now, good, that's how I change the slide. So for those who don't already know, the period 2021 through to 2030 has been designated the UN Decade of Ocean Science for Sustainable Development. It happens to coincide with a whole new era for the offshore industry and defense technology as well. So from my perspective, the 2021 to 2030 window also sees new investments in decommissioning, in seafloor mining, autonomous defense systems, a big upscaling of digital interconnectivity, subsea data and recharge systems, the demanning of offshore installations, development of carbon capture and storage, new hydrogen sector kicking in, the deep water aquaculture, smart pipelines, robotic repair, and many other areas as we go on, including possibly true artificial intelligence and quantum systems for deep ocean communications as well. So we see over this decadal period a transition towards almost making the ocean truly transparent, both for civilian and for military systems. So it's quite an exciting time for those of us involved in this field. So marine autonomous systems are very rapidly becoming the default solutions for quite a wide range of duties now. Those of you who were at Subsea Expo a few months ago in Aberdeen might recognize the Oceaneering Freedom vehicle shown in the photograph there. Freedom is still a fairly unusual class of vehicle, the hybrid autonomous underwater vehicle and remote operated vehicle. So it's combining aspects of the best features of both. It doesn't need to be tethered to the oil or gas platform or the mothership. You're able to deploy it. It goes off self-transits to the area of operation and then can recharge on these seabed mounted charging terminals. That's the thing there, the yellow with what looks like a strange QR code on top of it. The Oceaneering vehicle is able to position itself over the recharge terminal, top up its batteries, upload and download data, receive instructions, and then go off and do work rather like an ROV, using short distance blue laser communications to be controlled in real time. Once it's out of range of the laser communications, it carries on operating as an autonomous underwater vehicle until it's able to regain communications with a human operator. So systems like the Oceaneering Freedom and a new class of standard tools, standardized inductive charging, standardized system interfaces are already in their earliest days of becoming available. It's very much been led by industry, which is ahead of the defense sector in many of these areas, but we would expect to see that begin to change as we move into the middle part of this decade. So the marine autonomous systems, the advanced digital services, and the new sensors are already beginning to support the emerging blue economy. We'll see this phrase being used more and more in the next few years, and it refers to all of those means of generating wealth that work in a marine context. So we're going to be seeing, ongoing world of. Sorry, if you see me being distracted occasionally, it's because as I'm the person that controls the speech, I'm letting in the new arrivals who are joining as we go. So, like I said, this is the first time we've tried doing this. You might see a few strange distractions. Okay, back to where I was. So energy, fossil and renewable, still going to be key as we move throughout this decade, with, I suspect, the renewables portion taking off in an increasingly big way, especially in markets, like Europe and North America and the Far East. Minerals, the traditional ones, the things we've always been mining for, the aggregates, the shingles, the sands we need for building, but also now metals, and particularly the rare earths, to enable the future electronic economy. Food supply. Aquaculture already catches now over half of the tonnage of all of the fish and shellfish that humans eat, and that proportion will carry on going up. In the top right photograph there, it's a picture of one of the deep salmon farming offshore platforms that's been installed off Norway in the last couple of years. These are built in Qingdao in China, towed round into Norwegian waters at a much larger scale than the kind of fish farms that we used to see in shallow inshore waters in the past. They're incorporating many of the same lessons that have been learned in offshore oil and gas and renewable energy facilities, but utilizing them for offshore aquaculture instead. And these kind of large offshore plants will become very commonplace for both human food production and for other kinds of seafood as animal feed in the future. Another strand to this is an emerging industry of stem cell meat production. It sounds a bit gory and sci-fi, this idea of meat coming off in slabs on a conveyor belt somewhere, but basically you're using stem cells from animal, fish, or reptilian, or even insect protein. You're making muscles without having to make the organs or the bones or anything like that for the animal. So it's a very cheap and efficient way of making protein for human consumption, but it's also a cheap way of making protein for wild animal consumption. So if you're farming species such as salmon, which are naturally carnivores, at the moment you're having to catch perhaps 10 tons of a lower value fish in order to grow a ton of salmon. It's a very inefficient means of using fish resource. You're going out hunting one species to feed another one. If you're able to feed the carnivorous fish species with stem cell based protein feeds, you've cut out a massive step in that lack of efficiency, and it does mean that you're able to have quite high quality offshore meat production, whether it be salmon, halibut, or even the more expensive breeds in warmer waters such as tuna. So, and many of us in the offshore technology industry will find ourselves working in offshore aquaculture as well as in energy production in the future. The construction world, as we've seen from our Chinese friends, there's a lot you can do, particularly in an era of fairly rapid sea level rise and losing coastal facilities to erosion and just simply the lack of available land. The desire to use offshore technology to increase land area with artificial structures, artificial islands, even seasteading, we have free-floating human colonies drifting around, the high seas, has quite a lot of appeal for some developers, and I expect we'll see quite a lot more of that develop over this decade. Pharmaceutical industry already very heavily involved in the offshore sector, particularly exploration around hydrothermal vents and deep ocean resources, looking for the next generation of antibiotics, drugs. Some of you may have read in the news that the coronavirus, the COVID-19 test, one of the ones that's been used, it is derived from a deep sea organism. So, there is direct practical benefit to these kind of new introductions. And particularly in countries like the UK, quite a large part of our offshore industry are the support services, the legal side, the insurers, the policy, the finance, all of those things related to the oceans. Big industry, employs a lot of people, often, at a decent salary level. These are good quality jobs that will continue to exist even if there were no humans working offshore. The robots are still going to need to be insured. They're still going to get into trouble occasionally, and you need a good lawyer to sort out the mess. Defense and homeland security, this is going to become a real key area for growth in marine systems over this next decade, and we'll go on to that a bit more later on. And cables and pipelines, we're already seeing autonomous vehicles in widespread service inspecting cables and pipelines, but the cables and pipelines themselves are going to become smarter. We're going to see them with embedded sensor technology, and all manner of additional features that were never part of the original design as we progress into this decade. Now, here's an example of one of the new systems that we saw advertised just a few weeks ago. Some of us from SUT were at the launch at the Science Museum of the Armada concept that comes from Ocean Infinity. And Armada is a concept of 12 to 15 small remote operated survey ships that can do things like deploy ROVs, that can deploy AUVs, that can do the conventional side scan sonar or multi-beam type surveys of the sea floor. And this is now being brought to market. We'll see the real vessels being deployed quite soon to go out and do rapid sort of offshore, particularly coastal survey assessments, for specialist kind of customers. It could well be that within 10 years, by the end of the decade, that the idea of a survey vessel that actually has a crew on board could start becoming a rather rare and precious thing. Now, obviously, there are quite a lot of legal and policy obstacles to being able to use completely unmanned systems for these kind of jobs, as well as the technical issues. How do you repair it if it goes wrong or it manages to snag its cables somewhere? And in fairness to Armada, these aren't true autonomous systems. These are really remote controlled systems. There'll still be a human operator sat on the mothership or in a shore office somewhere. But it's just the beginning, and we'll see competitors come into the market delivering similar kinds of services. And as I said just now, I suspect by the end of the decade, we'll be tickled pink at thinking they used to actually send humans out to do this kind of work. Now, for offshore energy, the world didn't stop running steam engines because it ran out of steam. Steam gave way to hydrocarbons and other forms of fuel because the new things that came along were more efficient, and they were easier to do, and less polluting, and you didn't have the bulk of the coal to have to deal with, and all of these kind of things. And in a similar manner, there will still be millions of barrels of oil and gas left, in geological resources long after the demand has gone away. And the demand will go. We've still got 30, 40 years, of an offshore hydrocarbon industry. But if we're going to hit those zero net carbon by 2050 targets, and that's not just Britain, that's the whole world, And if we want to avoid dangerous sea level rise and climate change in excess of 2 degrees C, we will indeed find ourselves forced by policymakers and lawmakers, as much as anything else, to have to transition energy production to these new areas. Now, the prospects for gas are very, very good, because of course you can strip the carbon out of gas and feed straight into a future hydrogen economy. So I imagine the future of gas is pretty assured. And for the liquid hydrocarbons, there are, as we all know, 1,001 things you can do with oil in addition to burning it. So we're not going to suddenly see the world not want these products anymore, but they'll be using them in different ways. These will be, oil would be a feedstock for the chemicals industry, and for those parts of transportation and power infrastructure that can't easily be decarbonized. But we're already familiar with things like floating wind. That's now becoming a reasonably mature technology. It will be rolled out in greater and greater numbers over this next decade. We will, I'm pretty sure, also see large-scale floating solar. At the moment, we're seeing it on a fairly small scale in shallow, sheltered coastal waters, particularly in China. But there's no good technical reason why floating solar can't be rolled out on quite a large scale further offshore. And both floating solar and floating wind, I think, will find themselves being harnessed for offshore hydrogen production, through electrolysis of the seawater. And there you have many options how you get that hydrogen back to shore. You can either do it through pipelines, or you could have the hydrogen coming through feeder tankers, coming to visit the offshore facility, take off the hydrogen that's been generated underneath the offshore solar or the offshore wind plant, and or it can just be piped direct to onshore refineries. And there's lots of things you can do with hydrogen. You can either incorporate it into your gas grid, you can use it directly as a fuel, you can mix it back with captured carbon to turn it into a hydrocarbon, to ease the storage problem. You can use it in fuel cells. And we're already seeing now quite a few places in the world investigating in those sort of pilot projects to see, how do you have a large-scale, long-term sustainable hydrogen economy. Scotland is going to be a pioneering area for that. So are areas of the northeast. But we're also going to see this happening in Australia and in the States and in many other countries besides. Certainly the Norwegians are investing in this area. 2 weeks ago, just over 2 weeks ago, just before the lockdown, I had a visit to some of the facilities in Milford Haven, where they're certainly quite keen on being able to upgrade those oil and gas storage facilities and the pipelines in future to be able to turn them into hydrogen storage, production and transportation facilities. So for companies and individuals who are happier working with gases and liquids, hydrogen economy certainly offers us a clean, green means of still being able to meet energy demands, still using offshore resources and the expertise that the hydrocarbon sector has developed over the last century, except using it to produce hydrogen instead. And I'd be very, very surprised if hydrogen isn't a very significant industry, certainly by 2030, and possibly a few years before that. And this will be driven by tax incentives and legal incentives as well. This won't just be a technology barrier. This is up to how governments want to deliver their clean, low carbon futures. Now, if you're going to go down that route of clean, low carbon future, you're going to need access to some pretty high grade metals, both for battery technologies, but also for the electric motors that are going to be in the cars and ships and possibly even aircraft running off electric means over this next decade. It's already possible to buy a fuel cell car. Toyota are onto their second generation Mirai. It's just gone into production. Hyundai and Kia are also bringing hydrogen fuel cell powered cars onto the market. BMW are about to do so, and so several others. And I think we'll see over this next 10 years the gradual decline of the internal combustion engine powered car and its replacement by battery vehicles for short range use and hydrogen fuel cell vehicles for longer ranges, and possibly even commercial vehicles too. And moving into those areas will require access to the deep ocean floor to be able to get hold of some of the rare earth metals that are down there in seabed deposits. Tremendous opportunity for our offshore sector. Obviously, quite a few issues in terms of marine environmental impact assessment and understanding what the mining process could potentially do to deep sea ecosystems as well. So, you know, we can't just go around mining the stuff without making any effort at all to see what impact it has on the sea floor. So that means there's a big job there for offshore survey, for on-site inspection, for monitoring of the mining activities, understanding what impacts they're having, and alleviating them and mitigating them as appropriate. There's quite a few technical problems too. I was speaking to some Japanese engineers who'd been doing some work on, you've mined your material, it's down there on the sea floor. How do you get that seafloor material back up to the mining barge or the production support vessel? Through what kind of riser and lifting system are you going to use? And I'm told that there are still a few technical problems with the lifespan of the lifting facility, for example. If you have any kinks or bends in the pipe, that kind of metalliferous slurry, coming up that pipe is going to quickly wear down the kinks and the corners of the material as you are mining this. So we do have a few technical problems to get through. The Japanese are investing heavily in this. The Chinese are very, very interested. And in particular, they're doing quite a lot of buying up the survey licenses from the International Seabed Authority in Jamaica, so that they have the right to see what kind of materials are down there on the mid-ocean ridges. And in the future, when we start issuing the actual mining licenses, they'll doubtless be in the front row of the countries who wish to do so. Britain is very well placed to take part in deep sea mining. We have a lot of the expertise here. And because our friends in the United States didn't ratify the UN Convention to the Law of the Sea into their own domestic law, it means US companies who wish to take part in deep sea mining can't operate out of US-based offices. So what's tending to happen is that they're setting up their activities out of a London office, or sometimes a French, or one of the other ones that way. But deep sea mining, definitely going to be one of the areas we find ourselves working in. Another slide on that theme. Some of the deep sea mining machines are essentially glorified potato pickers. I had the good fortune to visit the National Institute of Ocean Technology at Chennai in India a few years ago. And they were basically engineering potato picking machinery to work at 6,000 meters depth and pick manganese nodules off the seabed. And they were doing a good job of it. So that was going to be out in the Bay of Bengal. Other countries developing similar technologies for whichever kind of materials they're interested in mining. So there's a couple more pictures on this page of the Bridges gliders, which are sort of hybrid AUV stroke gliders designed to be able to self-deploy to the operational area. There's the Deep Explorer that will operate down to a few thousand meters, but then the Ultra Deep Explorer that will go right down to 6,500 meters or more, and designed to loiter around a mining area, monitoring operations, checking on suspended sediment plumes, and being able to report back to the mothership, on the progress of the mining activity. It's also quite possible that these mining machines, as the technology improves and the power cells improve, that rather than having a machine that is tethered to a mothership and only mines while the mothership is present in the area, I foresee within not too many years a whole new generation of these machines that are entirely robotic. and, using self-contained power sources that will rove around the seabed, carrying out mining for extended periods of time, and then putting the mined material into collection locations, perhaps waiting until the metal price is right. And at that point, the mothership comes in and retrieves the ore from the seabed. So you could have an ongoing mining operation, but only bothering to collect the mined material when the markets were right to justify the cost of retrieving and bringing back to the surface. Accompanying this new generation of vehicles is also going to be a new generation of sensors. Perhaps one of the most exciting is the environmental DNA sensor. Now, this uses short strands of DNA. You could almost call it, marine mammal or fish dandruff. Particles, flakes of skin, flakes of hair, feces from creatures, all these kind of things, where the sensor is basically picking up these very, very small biological samples, amplifying the DNA, and being able to give you a readout of what kind of creatures live in a particular geographical area pretty quickly. Now, I had this demonstrated to me at Rockefeller University in New York a few years ago, where the postgraduate student went down to the East River with a 1 litre water bottle, took a 1 litre sample, came up, poured it into the machine. We went off and had a coffee, came back about half an hour later, and there was a printout showing about 30 species that were living in the East River. Now, it couldn't tell us the abundance of the species or how recently the creature had swum through that particular parcel of seawater, or semi-seawater in the case of the East River, but it could at least tell you what lived there. And you can imagine the implications of things like, fisheries research, pollution monitoring, marine environmental monitoring, quite astonishing for some of these kind of technologies, in forthcoming years. We'll be able to do quite a lot with this. It also has a rather interesting military spin-off. You might not be able to detect the submarine with an eDNA sensor, but you will be able to detect the submarine's crew. Submarines flush their toilets. You will end up with samples of human DNA floating around in the water column that might give you a clue about the approximate nationality and age profile and various things like that of the the humans that happen to be operating in that cube of seawater. So it might at least give you a clue there is a vehicle in the area that you might need to search by more active means. It also gives a lot of scope for those who wish to spoof the sensors, because you would be able to go into somebody's waters and deliberately release the wrong kind of DNA if you wanted to confuse your opponent as to who is around, snooping around in your seabed. So those lab-on-a-chip solutions are becoming available for a growing number of parameters you need to measure. And again, by the end of the decade, there won't be that many things that you need to measure that can't be done by some kind of high-tech means, as opposed to having to take a traditional sample and run it through a shore-based laboratory. The big issues are reliability of the systems, the calibration of the system, in particular, if you're putting seawater intakes onto any kind of autonomous platform that doesn't have a human around to clean the intake and clean the filter holes. If you're operating in shallow water, particularly sunlit shallow water, you will have biofouling of your sensors and the water intakes quite quickly. And that might turn out to be the operational limit for this kind of work. So it's not so much that the sensor can't do the job as that Mother Nature conspires to make sure that your sensor can't get any readings. Now, Europe is still a key player in developing state-of-the-art robots and sensors. We were very much in the lead in both autonomous surface vehicles and autonomous underwater vehicles, and in many respects still are. So you're seeing companies, such as ASV being bought up by L3Harris. You see, the AutoSub vehicle that I used to be involved with back in Southampton. I'm glad to see my former colleague Rowley is there on the list of attendees. So that's very good. these systems are becoming more and more capable. You know, we used to be delighted if we could send these things away for a week and they'd come back in one piece, and now they can go away for months at a time. And the limitation, as just mentioned with the sensors, is things like biofouling. You know, the battery endurance is gradually getting better and better, and that ties in quite strongly with the development of electric vehicles. The sensor technology is improving, the navigation technology. One area we do have to have quite a bit of concern about is the reliance for all of these autonomous systems on satellite navigation systems. They obviously they need GPS, or whether it's Galileo, whether it's Navstar, whether it's GLONASS, a lot of systems around. But all of these systems are very low energy. The beam coming down from space is a low energy source of radio energy. It's very easily jammed. You simply need to have a system that's broadcasting with a bit more power down at ground level. And the more sophisticated opponent doesn't just jam the signal, they put in an alternative signal, they spoof it. We've already seen this happen in some waters. It's happened in Norwegian waters, it's happened in the Baltic, and in a few other places in the world where malicious actors are deliberately interfering with navigation information to, for whatever reason they have. And we can anticipate that in a world that relies a lot on autonomous systems, whether it's road transport, air transport, ships, robot, scientific instrumentation, whatever it is, the temptation for people to go around and mess about with those navigation signals is going to be very, very high. And we need to have good, reliable, alternative means of navigation, autonomous means of taking star sites, sun sites, using cameras to look at coastal features, shapes of coastlines, using bathymetric sensors to check water depths. We will need to have backup systems to satellite. If your ship thinks it's 200 miles offshore, but there's a camera on board that says, hey, there's a cliff 5 miles away, that your satellite navigation system is not giving you accurate results. Of course, it's not just the West that's working on these autonomous systems and deep systems in particular. The Russians are investing some very substantial effort now in systems particularly for polar access. They want to be able to do their own deep sea mining and aquaculture and fish farming and obviously defense work in Russian waters out to 200 miles off their coast, well into the Arctic. And one of the areas the Russians are putting a lot of investment in is nuclear powered systems that will work under ice. So we're looking at seabed power modules, with small autonomous nuclear reactors able to power the seabed instrumentation. They're also the first country to be building for civilian use a large seismic survey submarine for Arctic operations. And I have an illustration there from my friend H.I. Sutton, a very worthwhile website and Twitter feed to follow. He calls it Covert Shores on Twitter, hisutton.com on the internet. And he's done some terrific work on classifying some of the systems that are becoming available and doing his artist's impressions, and quite a lot of information on there about marine autonomous systems as well. So lots happening there. And of course, our friends over in China, as is well known, have got very, very good at learning from the best of the Western systems, sometimes improving on them, sometimes not, but being able to duplicate them and sell them at a lower price. Some of these systems are becoming very, very sophisticated indeed. And those of us that go across to the trade shows and exhibitions in China never fail to be astonished at the speed and variety of the products that are coming off their production lines now. There's something like 250,000 Chinese students in Western universities at the moment, learning, from very, very good teachers how to do things very, very well. So we shouldn't be in the least bit surprised that they're returning home with the knowledge they've gained and producing some very high quality instruments, sensors, and robotic devices. I saw these ones. I was invited to give a talk in Hainan last October. The one on the top left there was it was being marketed as Roboshark. It was a biomimetic. By biomimetic, I mean machines that copy biological features. There's a prototype AUV that was actually been sold as having sound-absorbing skin, and because it uses a fish-like fin rather than a propeller, it moves very, very quietly. So if you want a sort of a covert system that's able to go into ports and harbors or stay close to people's military installations, it's quite a good way of doing it. Although perhaps you want to make it a little bit smaller and less shark-like. You don't want to attract the wrong kind of attention. There's a fair bit of evidence that China and some other countries are making some significant progress in quantum communications as well. So this is the ability to be able to communicate with objects even on the seabed through the quantum entanglement of electrons from orbiting satellites. So it's very low bandwidth. You might only be able to do things like send a yes, no, or on, off kind of instruction, but it does let you communicate with sensors you've placed on the seafloor or systems of various kinds. And that technology, along with true artificial intelligence, if it begins to emerge, vastly increases the capability of autonomous vehicles and robotic systems over this decade. We're not there yet on artificial intelligence, but if we were sat around these screens in 2030, who knows? It's entirely possible that things will have moved on to quite a different level of operation by then. Industry, in many respects, is well ahead of the armed forces in its use of robotic systems, but our friends in the defence sector are catching up fast. And I showed this slide again using one of H.I. Sutton's illustrations at a defence meeting in February. And it just goes to show some of the progress which has now been made on large autonomous underwater vehicles. There's a human for scale there against the top two images. So you have the LDUUV and the harpsichord, the top there from the US and Russia. The Chinese have just put the HSU 001 into service. The South Koreans are working on an anti-submarine warfare underwater vehicle. And the two big ones down at the bottom, you have the Orca extra large UUV from the US currently under development. And I suppose the daddy of them all, Poseidon, which is a Russian nuclear powered and nuclear armed autonomous vehicle, a NATO code name Canyon. And this is, again, it's coming into service. We believe there are about 32 of them on order for the Russian armed forces at the moment. The first Sea Lord in the UK announced in the end of February that M-subs in Plymouth have just been contracted to deliver the first large unmanned underwater vehicle for Royal Navy use as well. It's very expensive to build large manned submarines. There's a lot of gaps to fill in being able to patrol the oceans and carry out the various missions that submarines are required to do so. And so for many of the world's navies, I think will be deploying large and increasingly capable marine autonomous systems in the next few years. And these were some pictures from the October parade in Beijing, back in Tiananmen Square in October, of two of the HSU 001 systems being paraded through Beijing. Now, tying in with all these advances in the technology, you have to have the legal structures and the law right to do this work as well. The existing regulations were written for a pre-robotic era. So you assumed that there was a human lookout. You assumed that you would have people able to respond to distressed calls at sea, to render aid to ships that were taking on water. But all this begins to change when you take humans off the machine. So the existing regulations written for pre-robotic era, environmental protection has growing importance. We're already seeing the new rules on ballast waters and low sulfur fuels. There's a whole raft now of marine spatial planning laws coming into operation, particularly in the developed countries, but gradually these will be rolled out pretty much everywhere. New systems currently under development for areas beyond national jurisdiction, but at the same time, the international rules-based order has been seen to be at risk by assertive nation states who basically push at the edge. Just what can you get away with? Can we build things in what are supposed to be international waters? Can we ignore the international rules and do things our own way? So we are going to see these things being tested. The photograph there, for those you know him, there's our good friend Keith Brownton. Oops, I went one ahead there. Keith Brownton's there with Sir Julian Hunt, where SUT were invited to the House of Lords to participate in the meeting with the Advisory Committee on Ocean Resources. So it's one of the ways that we try and help interact. So the regulatory frameworks that need to adapt to marine autonomous systems include the UN Convention on the Law of the Sea, the International Convention on the Safety of Life at Sea, the Convention on the Standards of Training, Certification and Watchkeeping of Seafarers, the collision regs, and many others. National laws and regulations are all going to need to be revised in coming years to take account of robotic operation. And organisations like SUT as international global learning societies will have quite an important role to play in not just being aware of the technology, but working with the regulatory bodies, the licensing agencies, the lawyers, the accountants, the insurers, to make sure this is all done as well as possible. Area our Defence Committee is working on at the moment, legality of armed AUVs needs updating. There are other acts available, but the last major update in the law as it pertains to robotic systems was way back in 1907 with the Hague Convention Part 8, which was written for the users of moored sea mines and ship or submarine launched torpedoes. So how do you bring Hague 1907 into the world of the 2020s? Where we're now looking at quite clever, quite smart marine autonomous systems. How do you ensure their safe recovery? How are the robots identifying their targets? And critically, how does the robot know the war is over? The picture on the right is again, pertains to Poseidon Canyon, the Russian nuclear-armed and nuclear-powered autonomous underwater vehicle. Now, if that thing's gone off on a 6-month mission, how do you tell it that it's okay, you can disarm now or come back to base? What happens if it loses its communication system? Is it designed to be communicated with at all, or is it a fire and forget weapon? The deployment of this class of systems raises quite a lot of both legal problems, ethical problems, and technology problems. How do you counter it? How do you detect it? How do we use the other advanced technologies in our armories to make sure that one of these nuclear robots doesn't find its way into your port and harbour facilities? So last couple of slides, where do the learning societies like SUT fit in? Well, we exist to inform, to exchange knowledge, particularly between industry, government, and the academic side. We offer training, accreditation, events. Now, normally, of course, we'd all be meeting face-to-face, having a meeting like this. What COVID-19 is doing is forcing us to go down this online pathway. So who knows? Hopefully this will work. And before too many more months have gone by, we'll be able to revert to face-to-face meetings, but keep these online things as well, because I think these are going to make quite a difference in the future. We also exist to cross-fertilize ideas across the sectors to champion innovation and to build partnerships with our sort of fellow learned societies. So I'm going to stop that there. That's a picture of our Beijing branch. The students, we have one random Nigerian who happened to be working at the Petroleum University of Beijing. Otherwise, all the people in that photograph are students associated with our China branch. Now, I have the facility, I can unmute you all. Right, you're now unmuted. Now, if anyone wants to ask a question, there's not too many, because there's only 15. So if somebody just calls out and says who they are, you'll be, and I'll try my best to answer questions. I don't know if there's a stick up your hand facility on Zoom or not. I haven't tried this one before. But just...
That's a question. He says, I don't know if there's a stick up your hand facility on Zoom.
So, has anyone...
Sorry, Steve.
That's all right. I'll forgive you, John. Is anybody else out there?
Oh, you realise it's me? Oh, sorry.
Yes, we could hear you then. You weren't muted anymore. So,
Brilliant, actually. Thank you.
Right. Any questions? Oh, Joe. Yeah, I can see.
I was just confirming that there is a raise your hand facility.
Oh, okay, I can see it now. The window, my window had moved and it was covering the bit that said you'd raised your hand. So, yeah, I've got you.
Yeah,
I can see.
Yeah.
Great. So, Joe, any questions from you? I mean, you know more than most of us, particularly on the direction of travel for the autonomous systems and swarming techniques and things like that. I mean, I presume this is kind of on the right track of where it's headed.
Yeah, no, I think it's a pretty good overview. I think there's a lot in there. I think currently there's a lot of uncertainty around oil and gas with the low value of the barrel. Yeah, if anything, I think that calls for more automation, further automation, but also it's good to see that there's other opportunities for industry outside oil and gas as well.
Sure. Okay, thanks. Anybody else got anything? If you can't find the raise your hand button, then just holler out. Okey-doke. No, looks like we're probably about there then. So we'll try and make these a reasonably regular occurrence. The podcast series should start probably late-ish on Thursday, and we'll make those weekly. I don't know yet how regular the actual online Zoom seminar type things will go. That will depend on how many people we can get to speak, I imagine. Right, so I shall leave you all in peace then, if nobody else has any questions. Thank you for joining us, and we'll speak to you all again very, very soon. So
thanks, Steve.
Thanks, Steve.
Thanks.
Yeah, thank you, Steve.
Thanks all. Bye for now.
Right.
Bye.
Thanks, Steve.
Bye.
Cheers, Steve.
Thanks. Bye-bye.
Bye. Great, Steve.
Okay, thanks then.
Thank you. Sorry.
Right.
I'll do this back.
I think I click on the end button meeting and then it should go away.
Yeah.